Okay, so I want to look at number one, just to make sure everybody's on the same page here and what we're doing. So they give us the equation. Now there's a whole bunch of description of what's going on there, but we don't need to know all that. We just need to give our equation. This equation models the path of a ball being thrown through the air. Okay, so I'm just off to the side, just going to give a little quick sketch. We see that our y-intercept is 18. So I am not going to draw my ball starting from down here at the origin. I'm going to start it up here somewhere. And let's say that's my path. Okay? So this is a height of 18. And of course, this is the origin, so that's time 0. All right, so there's this little sketch of what's going on. Now, for part A here, it says, at what time does the ball reach its maximum height? At what time? So what axis am I working with? X-axis or Y-axis? The x-axis. Time is going horizontally on our little graph here. Time is always on the x-axis, folks. Okay? Time is always on the x-axis. So, they want to know what time does the ball reach its maximum height. So that means maximum sounds to me like a vertex position. And we want to know what time. So we want to know what x value. Well, that maximum position is the vertex of the parabola. So are we looking for the x-coordinate of that vertex or the y-coordinate? Yeah, we're looking for the x-coordinate. Well, we learned how to find the x-coordinate for a parabola written in standard form. How do we do that? Exactly, negative b over 2a. Well, in this case, we're not dealing with x's, we're dealing with t's. So I'm going to write t equals negative b over 2a. So, plugging into that, we have negative 64 over 2 times negative 16. Well, that's negative 64 over negative 32, which is 2. So therefore, the ball is reaching its maximum height at 2 seconds. Oops. Questions? Okay, so that's then the x-coordinate or t-coordinate of our vertex. Part B says, what is the maximum height? Well, what are we looking for there? The y. Remember when we talked about parabolas, before we talked about modeling balls flying through the air, we said that the maximum or minimum value of our function was the y-coordinate of our vertex. Right? Well, that hasn't changed. That's still what it is. So the maximum height of this parabola is going to be the y-coordinate of that vertex. So to find the y-coordinate, I've got to plug my x-coordinate in. Well, we just found the time, so therefore for part B, we're going to find the height by plugging 2 back into our equation. So we have negative 16 times 4 plus 128 plus 18. What is negative 64 times 4? Is it 64?
Yes.
16 times 4?
64, yeah.
Yep. Plus 128 plus 18. So, negative 64 plus 128, that's a positive 64. 64 plus 18? 82. So, at 2 seconds, our ball is 82 feet in the air. That is then the maximum height. Any questions there? So notice, we answered those two questions, A and B, simply by finding the vertex of our parabola. That's all we were doing, is finding the vertex of the parabola. We answered two questions. At what time does the ball reach the maximum height? And then what is the maximum height? All right? Now for part C, they ask us at what time does the ball hit the ground? So at what time does the ball hit the ground? The ball hits the ground over here. And what's the height of the ball when it's sitting on the ground? 0. So we know that our height is 0, otherwise known as the x-axis. So we're going to plug 0 in for h. And now we've got to solve that equation. We have a quadratic equation. We learned how to do this in Unit 1. It's set equal to 0, so we called that standard form. We still do. Okay? And to solve that, we could have solved this by factoring. We could solve this by completing the square. We could solve this by all those fancy ways we learned. But the most straightforward way of solving this is the quadratic formula. Solving for t, it's going to equal negative b plus and minus the square root of b squared minus 4ac all over 2a. So, t equals negative 64 plus and minus the square root of 64 squared minus 4 times negative 16 times 18 all over 2 times negative 16. Now, if you go through and work this, you're going to have to use a calculator, obviously. Please remember, we're not trying to simplify this and get an exact answer anymore. We want to get a decimal answer. We want to know approximately how many seconds. We want to be able to count how many seconds. And if you're reducing a square root and getting 8 times the square root of 13, they don't shout that number out at track meets. Okay? We need to actually find the decimal answer here. So, when you do this, you need to take 64 squared, gives you a big number, I think it's 4,000 something. 4,086, okay? 96, all right. And then we got to take negative 4 times negative 16 times 18, which again gives us a positive number. And if you add those two numbers together, you're going to get negative 64 plus and minus the square root of 5,248 over negative 32. Okay, well great. Keep working. What's the square root of 5,248? 72.4. Yeah, 72.4. We can round it. That's fine. So 64 plus and minus 72.4. all over negative 32. Well, again, we've got to find our two answers. So you've got to take negative 64 plus 72.4 and then divide that by negative 32. So we get our time to be approximately negative 0.27, right?
Yeah.
Yeah. And you need to take negative 64 minus 72.4 and then divide that by negative 32, and you get your time to be approximately 4.27. Well, do both of these answers work? Why not? Okay, but why can't we have negative time? Can't go backwards in time. This ball cannot land on the ground 0.27 seconds before we throw it. That does not make sense. This one does not make sense. The answer is 4.27 seconds. Okay? And if you look back at the graph, it'll show you that we're not talking about that part of the graph. Right? If you look here, this is 4.27 seconds, roughly. Well, we had that other part of the graph over here that we said we weren't paying attention to. The other part of the parabola. Back here is that negative 0.27. Well, that's not even part of what's going on. We're not paying attention to anything back here because, again, we can't have negative time. Time starts at 0 and goes forward. It does not go backwards. Okay? Questions on number 1, parts A, B, or C? All right, so in problem number 6, they give us the equation, or actually they don't give us an equation in this one at all, they actually give us some points, and all we need are 3 points. So I'm going to use 0, 5.5, I'm using 1, 6, and using 2, 5.5. Okay, so there's our 3 points. They actually give us 4 points, but we only need 3 of them. Okay, and we want to go through and find the equation that models this data. So we're basically writing an equation given these 3 points. So we go through, we start out with our standard form. And this first point gives us what? C. Because that's always our y-intercept. So C equals 5.5. Well, now we need to find A and B, so I use my second point. So therefore, 6 equals A times 1 squared plus B times 1 plus C. And multiplying that out, whoops, I'm sorry, not plus C. What's C equal? Yeah, C should be 5.5. Okay, and we need to then subtract 5.5. So we now get 0.5 equals A plus B. There's an equation we need. Okay, we need our equations that have A and B in them. So let's go ahead then and use our third point. Gives us 5.5 equals A times 2 squared plus B times 2 plus C, which is 5.5. So subtract 5.5 from both sides. 5.5 minus 5.5, 0. 2 squared is 4a plus 2b. So there's our second equation dealing with a and b. So we use those two equations. And let's see here. We have 0.5 equals a plus b, and 0 equals 4a plus 2b. Anthony, which variable do you want to get rid of, a or b? A. So therefore we have to multiply that top equation by what? By negative 4. So what is negative 4 times 0.5? Negative 2. Negative 4 times a minus 4b. So we are now using these two equations here. We're going to add those together. So 0 plus a negative 2, negative 2, 4a minus 4a, and 2b minus 4b So let's go ahead and divide both sides by -2. So we now see that b equals 1. Okay, well, the last thing we need to do is solve for a. So I'm going to take one of our equations and let's go ahead and use this one. Because that looks like the easier of the two in my opinion. So let's go ahead and plug b into that equation. So we have 0.5 equals a plus 1. So to solve for a, we have to subtract 1. What is 0.5 minus 1? There's our a value. So the equation here is going to be, let me move this to the side. The equation is going to be y equals negative 0.5 x squared plus 1x plus 5.5. Okay, so there's the equation. That's the part A answer. Any questions there? That's the answer for number 6, part A. Yep. Now, for number 6, part B, it says to use our model, otherwise known as using our equation, to estimate the height of the ball at 4 seconds. Well, that's exactly it, because remember, they give us that information. Time is x, and height is y. I said that yesterday. And so we can think of all of our points. We can think of all of our coordinates, all of our points, being in t, comma, h coordinates for x and y. So therefore, if I wanted to, I could rewrite my equation saying h equals negative 0.5 t squared plus t plus 5.5. Now, I don't necessarily have to do that, but I can. It's no big deal. Okay. And they want to know what the height is at 4 seconds. So we're plugging 4 in for t, or x. So our height is going to be negative 0.5 times 4 squared plus 4 plus 5.5. Well, what is 4 squared? 16. And what is 16 times negative 0.5? So you have negative 8 plus 4 plus 5.5 is 9.5. And negative 8 plus 9.5 gives us a height of 1.5. And the measurements they all gave us in here are feet, so therefore this answer is in feet. There's our answer for number 6, part B. Any questions there? Okay, well, the next thing we need to do then is part C, which says, what's the ball's maximum height? Well, we have talked about this. Question? In a parabola, the vertex gives us our maximum height, or minimum height, right? Because we found maximums and minimums of parabolas. So that's what we're going to do here, is we need to find our vertex. So finding the vertex means we need to take x equals, or in this case, if t is our x value or x coordinate, t equals negative b over 2a. That's how we find the x coordinate of our vertex. So negative b, that's negative 1 over 2 times negative 0.5. Well, what is 2 times negative 0.5? Negative 1. So therefore, our time is 1. Well, now at this point, if you wanted to use that table of values, you certainly could. Because they say that our vertex, or our ball, or whatever our projectile is, I think it's a tennis ball in this case, our tennis ball reaches its maximum height at 1 second. Right? Well, if you look at the table of values they gave you, they say, well, wait a minute, at time 1 second, the height is 6 feet. Right? So therefore, yeah, you can see that their maximum height then is definitely 6 feet. But if they didn't give us that table of values, or maybe that point wasn't on the table of values, what we would have to do is take that time and plug it back into our equation to find our height. Our height equals negative 0.5 times t squared plus t plus 5.5. Well, we're plugging 1 in for our time. So 1 squared is 1, so I've got negative 0.5 plus 1 plus 5.5. So negative 0.5 plus 5.5 gives us 5, and 5 plus 1 gives us 6. That is our maximum height. Any questions on this problem? All right, looking at your review here, let's take a look at number 1. This is written in vertex form, so please make sure you have your notes handy when you're working through this so you can look back at, well, what is vertex form? What does that even mean?
What section did that start?
4.1. So we have y equals a times x minus h quantity squared minus, or plus k, excuse me. H and k gave us our vertex. It's exactly, our vertex is located at 4, negative 2. So that means that our axis of symmetry is the line x equals 4. Okay? Also, does this parabola open up or down? Up, because a is positive. So that means we have a minimum value of negative 2. They didn't ask for that information, but, you know, just to have practice as far as finding it, all of that information comes from the vertex. Well, let's go ahead and graph what we have here. We have our vertex at 4, negative 2. So 4, negative 2 is sitting right here. Our axis of symmetry runs vertically through that. And we now need 2 more points on one of the sides, either the left or the right, of our axis of symmetry to be able to graph our parabola. So, as you guys have heard me say before, let's just pick 2 values to the right side. Okay, so therefore we want x being 5 and 6. So we take our x values and we plug it back in to the original equation. So y equals 5 minus 4, quantity squared, minus 2. What's 5 minus 4? 1 squared. 1 minus 2. So when x is 5, y is negative 1. And let's try 6. Y equals 6 minus 4, quantity squared, minus 2. So 6 minus 4 is 2. 2 squared, 4 minus 2. All right, so we're at 5, negative 1. We are at 6, 2. And remember, we need to mirror our points to the other side of the axis of symmetry. So this guy gets mirrored 2 units to the other side. This one down here, this guy gets mirrored 1 unit to the other side. And we then draw our parabola. In number 2, this parabola, this quadratic equation, is written in vertex form. So we can immediately look at this and find our vertex. Remember, x is hexed, y is y's, so what's our vertex? -2, -1. So I'm going to go to -2, -1. And remember, we have then an axis of symmetry that goes vertically through that point. That axis of symmetry has the equation x equals -2, right? To graph this, then, I need to plot points, right? I plot points that have x coordinates 2 to the right of my axis of symmetry. So what are my x values here?
-1 is 0.
-1 and 0. So plugging in, y equals 1/2 times -1 plus 2 quantity squared minus 1. -1 plus 2 is 1. 1 squared is 1. 1/2 times 1?
0.5.
1/2, or yeah, 0.5. And what's 0.5 minus 1? So when x is -1, y is -1/2. Okay. Well, let's find out when x is 0. So y equals 1/2 times 0 plus 2 squared minus 1. 0 plus 2 is 2. 2 squared is 4. 4 times 1/2?
2.
2. 2 minus 1.
1.
So when x is 0, y is 1. Plot your points. We're at -1, -1/2. We're at 0, 1. Our points need to be mirrored to the other side. And now all we need to do is draw our parabola.
And you don't shade on these ones, right?
This is an equality. Equalities you do not shade. You only shade on inequalities. Okay, so number 5, we're still graphing a parabola, but this time it's written in standard form. So just like with vertex form, the first thing we want to do is find the vertex of our parabola. But in standard form, to find the vertex, you have to use the equation x equals -b over 2a. So plugging into that, that's -12 over 2 times 2. 2 times 2 is 4. -12 divided by 4, -3. So the x-coordinate of our vertex is -3. We then want to find the y-coordinate of our vertex by plugging that back in to the original equation. So 2 times -3 squared plus 12 times -3 plus 17. What's -3 squared? 9. What's 9 times 2? So I've got 18 minus 12 times 3 is 36 plus 17. So 18 minus 36 is 18, and 18 plus 17. Yeah, it's -18 plus 17. Thank you. It's -1. So our vertex is located at -3, -1. So we have an axis of symmetry at -3. This parabola opens up because a is positive, so we have a minimum value of -1. And if we graph this, we have -3, -1 sits right here. We have our axis of symmetry. And in standard form, a lot of times we don't only have to plot one point because they give us the y-intercept in standard form. The y-intercept is 17 in this case. It's always c, right? Well, that doesn't help us in our graph because 17 is clear off our graph. So we're still going to need to plot 2 points. So what two x values am I going to want to use? -2 and -1. I could have used -4 and -5. I just need to pick 2 points on one of the sides. I usually go to the right. So -2 and -1, we got to plug those back in. y equals 2 times negative 2 squared plus 12 times negative 2 plus 17. So negative 2 squared is 4 times 2 is 8. 12 times negative 2 is negative 24 plus 17. What do we get, folks?
1.
We get 1? Okay. Let's see then. Let's plug in negative 1 for x. Y equals 2 times negative 1 squared plus 12 times negative 1 plus 17. So this gives us 2 minus 12 plus 17. What do we get? 7. So there's our two coordinates. We go negative 2, positive 1. We go negative 1, positive 7. And again, we mirror those 2 points to the other side of the axis of symmetry. For number 6, we are graphing a parabola. This one is written in standard form. So, to find the vertex of our parabola, we need to use what little equation? X equals negative b over 2a. So, we have negative 8 over 2 times 2. That's 8 over 4, which gives us an x coordinate of 2. Plug that back in. Y equals 2 times 2 squared minus 8 times 2 plus 9. 2 squared is 4 times 2 is 8 minus 16 plus 9. So our y value is 1. Our vertex is then at 2, 1. So we plot that point. 2, 1 sits right there. We have an axis of symmetry at x equals 2. Now, usually I'd say plot 2 points to one side. Question?
Where'd you get the 2?
Okay, so our vertex is at 2, 1. We plotted our point. We drew our axis of symmetry. Like I said, usually I find 2 points on one side, but standard form gives us a point. The y-intercept, located at 0, what?
9.
9. C in standard form always gives you the y-intercept. So if we go to 0, 9, that gives us a point on our graph. Notice, we have an x value of 0, we know it's at 9. We have an x value at 2, we know it's at 1. There's an x value between those two at 1. So use that point as your other point. So we plot a little t-chart when x equals 1. So y equals 2 times 1 squared minus 8 times 1 plus 9, which is 2 minus 8 plus 9, which is 3. So when x is 1, y is 3. There's our other point we needed. Mirror the 2 points we have on the left side over to the right side. And then draw your parabola.
Are we gonna miss points if we don't show you that we plugged it in?
Yes, I want to at least see the work for this.
Okay.
When you're plugging something in, at least show me that you actually plugged it in.
Show you work just for when you're plugging the x, y in. When you're plugging the one in there, just show you that.
Yes, show me. I need to know where you got that 0.13.
Okay.
Yep. Okay, looking at number 9, we have an inequality written in standard form. So again, the first part of this process is the exact same as number 5 that we worked. Okay? We need to go through and we need to graph our parabola from standard form. So the first thing we do is we find the vertex. X equals negative b over 2a, which is negative 8 over 2 times 1. So negative 8 divided by 2 is negative 4. We plug that back in. So we have negative 4 squared plus 8 times negative 4 plus 12. And negative 4 squared is 16. What is 8 times negative 4? Negative 32 plus 12. So 16 minus 32 is negative 16. Negative 16 plus 12 is negative 4. So our vertex is located at negative 4, negative 4. Plotting that point, negative 4 brings us right here. Remember, the axis of symmetry runs vertically through that. It's the line x equals negative 4. Again, in standard form, we can usually find our y-intercept. But in this case, it's 12, so that's way off our graph, so it doesn't help us. So we still need to find 2 points to the right side or left side. Negative 3, negative 2. Okay, so we're using negative 3 for x and negative 2 for x. Plugging that in. Y equals negative 3 squared plus 8 times negative 3 plus 12. 9 minus 24 plus 12. So we have what, negative 3? And plugging in negative 2. So we have 4 times negative 16 plus 12. Or sorry, 4 plus or minus 16 plus 12. So that gives us what? 0. Okay. Plot those points. Negative 3, negative 2, 0. Mirror those to the other side of the axis of symmetry. And now we got to stop a moment. Now we've got to stop. We've got to look back at what type of inequality we're dealing with. This is a less than or equal to, so yes, we graph this with a solid line. All right, well next we need to go and find out where to shade. So in determining where to shade, we need to go ahead and find a test point. It sure can be 0, 0. 0, 0 sits right here, definitely outside the parabola. So let's test it. Testing 0, 0, we have 0 is less than or equal to 0 squared plus 8 times 0 plus 12. Well, 0 squared is 0, 8 times 0 is 0. So that means 0 is less than or equal to 12. True or false? That is true. So therefore, outside the parabola is the true side. Inside the parabola is the false side. We always, always, always shade the true side of our graph.
Hey, can you do 11?
Okay, so for number 10, we are graphing an inequality written in vertex form. So first off, we need to go ahead and find our vertex. Well, it's written in vertex form, so that's easy to do. Where's our vertex? X is hexed, Y is Ys. So it is positive 3, negative 2. X is hexed, Y is Ys. So our vertex is at 3, negative 2. So that then also means that we have an axis of symmetry at x equals 3. So let's go ahead and plot what we know. Our axis of symmetry is at x equals 3. We have our vertex at 3, negative 2. Okay, and then to graph this, we need to find 2 more points. Okay, I usually stick to the right side. So what 2 x coordinates do we want to use? 4 and 5. So we plot points using a t-chart. We use 4 and 5 as our x coordinates. So I have y equals negative 4 minus 3 squared minus 2. Well, 4 minus 3 is 1. 1 squared is 1. So I have y equals negative 1 minus 2, which is what? Negative 3. Let's plug in 5. Y equals negative 5 minus 3, excuse me, 5 minus 3 squared minus 2. So 5 minus 3 is 2. 2 squared is 4. So I have y equals negative 4 minus 2, which is negative 6. All right. Plugging that in, or plotting those points, I mean. We're at 4, negative 3 brings us here. We're at 5, negative 6 brings us here. And we need to mirror those to the other side of our axis of symmetry. So that first point gets mirrored over to there at 2, negative 3. Our second point gets mirrored here to 1, negative 6. Okay, stop what you're doing for a moment. We need to go through and decide, are we graphing this with a solid or a dashed line? Why is it dashed? Because it is just less than, not less than or equal to. So if it's just less than, we do it with a dashed line. Anytime you have an inequality, you have to shade. Yep, so we're not done yet. We still have to shade this guy. So what test point do we want to use? 0, 0. 0, 0 is sitting up here in the corner of our graph. So let's test it. Testing 0, 0. 0 is less than negative 0 minus 3 quantity squared minus 2. What's 0 minus 3? Negative 3 squared? Positive 9. So we have 0 is less than negative 9 minus 2. Because that negative was out in front of the parentheses, right? Yeah. Okay, well negative 9 minus 2 is negative 11. Is 0 less than negative 11? No. So that means this is the false portion of our graph. This is the true portion of our graph. You always shade the true side.
Just be like what we were doing, except without the graphing part.
Well, yeah, for number 11, basically, yeah, exactly. You need to find your vertex first. So find your vertex by taking x equals negative b over 2a, which is negative 8 over 2 times negative 2, which is negative 8 over negative 4, or 2. We plug that back in. Negative 2 times 2 squared plus 8 times 2 minus 11 is negative 8 plus 16 minus 11. So what do we get here? Negative 3. So our vertex is at 2, negative 3. What's our a value? The a value is negative 2. That just comes right from the equation. And so therefore, vertex form is y equals a times x minus h quantity squared plus k. So all we need to do is plug in our vertex, plug in the value of a, and we have our equation. X minus 2 quantity squared minus 3. That's the answer. That's the equation written in vertex form. They want us to write the equation in standard form. So, this is actually easier than the other way around. Okay? So all we need to do, if we're already given vertex form, is multiply it out. Okay, we've got x minus 5 squared. All right, well, let's find out what x minus 5 squared is. So that means we take x minus 5 times x minus 5. Minus 6. Well, x minus 5 times x minus 5, we need to FOIL that. We need to take x times x, which is x squared. X times negative 5 is negative 5x. Negative 5 times x is negative 5x. Negative 5 times negative 5 is a positive 25. Minus 6. So, all we have left to do is combine some like terms, and we'll have our standard form equation. Y equals x squared minus 10x plus 19. That's it. That's all there is to it. Yes, ma'am. Number 14 asks us to go through and rewrite this in standard form. Currently, it's in vertex form. This is much easier to do than vice versa, okay, which I believe number 12 or 11 we worked together. That one, this is much easier than that, okay, because all we need to do here is multiply this all out. Okay, we don't have to find the vertex. We don't have to find those things. We just need to multiply this out. So I got to do my parentheses, my exponents first. So I have 2 times x minus 2 times x minus 2 plus 1. Well, x minus 2 times x minus 2, I've got to FOIL that. So I have 2 times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is another negative 2x. And negative 2 times negative 2 is a positive 4. I can combine like terms. Negative 2x minus 2x is negative 4x. And now I've got to distribute my 2 through. So 2 times x squared is 2x squared. 2 times negative 4x is negative 8x. 2 times 4 is 8 plus 1. And again, I have to combine like terms. So standard form is y equals 2x squared minus 8x plus 9. In number 17, they want us to write the equation of a parabola that opens up or down. Well, all of our parabolas open up or down, okay? And passes through the points negative or 0, 2, negative 2, negative 6, and 5, negative 13. We're writing it in standard form. So standard form is y equals ax squared plus bx plus c. Looking at those points, do they give us some information? Some good information? They give us c. Because the y-intercept is always c. So therefore, c equals 2. All right, so c equals 2. Now, we can use the second point they give us to try to find a and b. So we're going to take that second point and plug it into our equation. So negative 6 equals a times negative 2 squared plus b times negative 2 plus c. So negative 2 squared is 4. 4 times a is 4a. Yes? Thank you. C is 2. We've got to plug in for that. All right, so negative 2 times b is negative 2b, and I have plus 2 for c. So we've got to subtract 2 from both sides. So negative 8 equals 4a minus 2b. So there's one of our two equations. Well, to find the other equation we need, we've got to use that third point. So negative 13 equals a times 5 squared plus b times 5 plus 2. I'm going to subtract the 2 first. 5 squared is 25, so I've got 25a plus 5b. There's our second equation. Now, we go through and solve for a and b using the process called elimination. So negative 8 equals 4a minus 2b, and negative 15 equals 25a plus 5b. I suggest using the smaller numbers, meaning I suggest trying to get rid of b. But notice, we need to go through and multiply both equations by something. Because there is no number that you can multiply -2 by to get 5. Furthermore, there's no number you can multiply 4 by to get 25. So we got to multiply both equations by something. Okay? Again, I want to get rid of the b. So, I'm dealing with a -2 and a 5. What is a number bigger than 2 and 5 that they both go into evenly? 10. They both go into 10 evenly. So, -2 times what gives you 10? So take that whole equation times 5. And 5 times what gives you 10? 2. So take that entire equation times 2. So we get -40 equals 20a minus 10b. And we get -30 equals 50a plus 10b. And we add these equations together. The b's go away. Divide by 70. A equals -1. Now that we know A, we grab one of these equations and plug in for A. -8 equals 4 times -1 minus 2b. And we solve. Add 4. Divide by -2. I'm speeding up so that you guys can get to lunch here. So b equals 2. Well, therefore, we know our c value is 2. Our a value is -1. Our b value is 2. So our equation is y equals -x squared plus 2x plus 2. Number 18, we want to go through and write the equation of our parabola that passes through these 3 points in standard form. So standard form is y equals ax squared plus bx plus c. Looking at these points, do they give us a special point? Yes, which one? 0, 10. Therefore, what does that give us? C. C equals 10. C is always the y-intercept, so C equals 10. Next, we need to go through and find A and B. So I'm going to use that first point, -3, 7, and plug it in. So 7 equals A times -3 squared plus B times -3 plus C, which is 10. I'm going to subtract 10 from both sides. So -3 equals, well, -3 squared is 9. A, -3 times B is -3B. There's one equation dealing with A and B. Yes, ma'am?
Do we always use the point first to find C? We always use the point 0 something?
Yes, because that's always the y-intercept, and C always gives us the y-intercept. Okay? All right, we need a second equation with A and B, so we go to our last point they gave us, -6, 22. So 22 equals A times -6 squared plus B times -6 plus 10. We subtract 10 from both sides. So I have 12 equals, well, -6 squared is 36A minus 6B. There's our second equation using A and B. So we now use elimination to solve for A and B. So we've got -3 equals 9a minus 3b, and 12 equals 36a minus 6b. How are we going to make one of our coefficients opposites so that either the a or the b go away?
Multiply by 2.
Multiply by -2. Multiply the top one by -2, because then what happens is we get 6 equals -18a plus 6b.
Why is it always -2?
It's just coincidence. Yeah, there's nothing special about the -2. It's just it's coincidence that in a lot of our examples it's been -2. Okay? So I'm sorry we didn't get a chance to finish this guy. If you guys look online today, it will be finished. Okay, so then we add these together. We get 18 equals 18a. -6b plus 6b go away. So to solve for a, we divide by 18. A equals 1. Now we need to solve for b. So I'm going to take this equation here and plug a into that. So I have -3 equals 9 times 1 minus 3b. So -3 equals 9 minus 3b. Subtract 9 gives you -12. And so now we need to divide by -3. So b equals 4. So therefore, we know our a value, we know our b value, we know our c value. We can write the equation y equals 1x squared plus 4x plus 10.